Jess, if I switch to another screen, can you see that on the screen now? Or can you still see the presentation?
Nope, I'm seeing your presentation.
Excellent. Perfect. Don't want to reveal my speaking notes. So, thank you everybody for joining this talk, which Jess Korte has very kindly agreed to give on Auslan Alexa, the Auslan Communication Technologies pipeline project that she is working on. I think many of you already know Jess because I can see a lot of people from the School of ITI on the Zoom call. So that's really great. So you probably already know how passionate Jess is about the ways that good technology can improve lives. So to ensure that technology is good, as she said in her bio, she advocates involving end users in the design process, especially when these people belong to difficult user groups, which usually translates to minority user groups. Her philosophy for technology design and life in general is that the needs of people who are disempowered or disabled by society should be considered first. Everyone else will then benefit from technology that maximizes usability. And Jess's research areas include human-computer interaction, machine learning, and participatory and collaborative design. So you might have noticed that we are recording this session, and we also have enabled Zoom captions. So in order to be able to see the captions at your end, you might need to be able to actually change your Zoom settings if that's something of interest to you. The recording will include the Zoom captions so that it will be accessible to people who might not otherwise be able to hear the presentation. So I thought you'd be interested to know that, given that this presentation is in recognition of Global Accessibility Awareness Day, which was last Friday. So before we continue, I would like to acknowledge the traditional owners and their custodianship of the lands on which we meet, recognising that we're on Zoom, so we're probably meeting from a range of different areas, but probably mostly the Yuggera and Turrbal lands. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australian and global society. And I'd also like to express my commitment to diversity and inclusion, given that this is an event that's been initiated by the Equity, Diversity and Inclusion Committee. And as usual, shout out to Sandra Hall for bringing this particular statement to my attention as a way of signalling the importance of diversity and inclusion, and the fact that diversity of thought can lead to more creativity and innovation and problem solving, which is obviously very strong in our faculty, given the disciplines that we teach and research. So we want to celebrate and be enriched by our differences. So on that note, I'm going to stop sharing and hand over to Jess to start her presentation.
Thank you very much. Okay. Are you now seeing the presentation view of my PowerPoint? Yep, excellent. Cool then. So my talk today we've called Auslan Alexa, because that's the metaphor that we keep using for my current project, which is formally titled the Auslan Communication Technologies Pipeline Project. So as Karen said, we do have subtitles and live transcription available for this talk today. Just in case you're not sure where to find those, if you're on desktop, you should have live transcript at the bottom of your screen. If you're on a phone, you'll need to hit more and then find it in the full transcript in the list. I apologize in advance if the transcription is a little bit funny. I have personally experienced that it's not great at technical terms like Auslan. I don't actually have it turned on my side. I don't know what came up just then. But if the transcript doesn't look right, I'm sorry. They're pretty good. They're not perfect. Okay, so I want to start off by asking, how do you control technologies? Have a bit of a think. Probably the traditional approach is going to be keyboard and mouse. More and more recently, we've been seeing touchscreens. And we're beginning to get a revolution in voice-controlled technologies. These voice-controlled technologies are becoming more and more commercially available and have an expected level of good enough for mainstream languages. English in particular, obviously, you have a lot of options. You've got the Amazon Alexa, the Google Home, Apple Siri, Microsoft's Cortana, some of which are available as individual devices, some of which come embedded in your phone. And they're a great technology. They're enabled by the fact that AI has got to a point where we can throw vast amounts of spoken and written language data at a black box, and it comes up with the model that goes, this is the signal I'm hearing. That's what that means. I can do something with that. And this gives us a promise of ubiquitous computing. Theoretically, at some point in the future, we can have computers literally everywhere, and every interaction will be a natural one, because you'll just be able to say, computer, report the location of Commander Riker. Or, possibly more useful everyday commands. Now, the problem that we have is that these are actually inaccessible to deaf people. The research has been done that shows that for deaf people who like to speak, even if their deaf accent, as it's called, is perfect, to a hearing person, we find that Alexas and other of these conversational user interfaces can't actually distinguish them. And I've not experienced it personally, but one of my research assistants is a coder, which is a child of deaf adults. Her English is absolutely flawless. They have an Alexa and it does not understand her voice. She has to ask her partner to please repeat her commands to make the Alexa behave. Now, some of the voice-based personal assistants have text-based input options, which they claim is appropriately accessible. It's not really. It is not the equivalent to be able to stand in the kitchen with your hands dripping because you've just been kneading dough and say, Alexa, what's the next step? Or Alexa, preheat the oven. If you're having to put it down, wash your hands, type something, you may as well just turn on the oven yourself. You're not getting the benefit that we claim to have of conversational voice-based technologies. So deaf people around the world have said that actually, yes, I would be interested in using a sign language assistive device. Not everyone, obviously, as you can see, but enough people in the particular study this graph is from was American, USA, deaf people, and it was a combination of deaf and hard of hearing people. The research that I'm doing at the moment, we're focusing on deaf sign users, so not so much people who speak as well as sign. And I don't have the statistics yet because we're still working through and translating all of the interviews that we've been doing, but the overall impression has been a lot of people are interested. They don't necessarily know if they would want one in their house, don't necessarily know if they'd want to buy one, but desperately want to see what can we do in this space. So my project is the Auslan Communication Technologies Pipeline. The idea behind this system was that it will be a Auslan in, Auslan out system, so that a fluent signer will be able to sign a command. It will be recognized by the recognition system. It will be processed and acted on by the device. And then it will produce a response also in Auslan. Now, obviously, I'm working in Auslan because it is the sign language of the Australian deaf community. Now, there's some very important considerations when it comes to creating good sign language technologies. It's Zoom, so I can't really ask for people to put their hands up, but some of you may have heard of the term disability dongle before. Some of you won't have, and that's fine. I particularly like this term. It was coined by Elise Jackson, who is a disability advocate. And it's, as you can see, a well-intended, elegant, yet useless solution to a problem we never knew we had. Disability dongles are most often conceived of and created in design schools and at IDEO. Examples would be every couple of years, there'll be a new report of a wheelchair that is able to roll up the stairs. This is not a thing that people in wheelchairs have ever said they wanted. They really just want people to put in ramps. There's all sorts of technical problems with having a wheelchair that rolls up the stairs, including vastly increased likelihood of the wheelchair tipping over halfway up the stairs and you falling out. The fact that it would be much more expensive when wheelchairs and other assistive devices are already incredibly expensive. And in Australia, if you're trying to get it through the NDIS, there's about 1 million hoops to jump through. That's a different conversation, but getting even baseline assistive technology is very difficult and expensive. And disabled people are rightly saying, we don't want more expensive, inaccessible technologies when there are easier solutions. Sometimes expensive technologies can solve a problem, but you have to actually ask disabled people, is it a problem they're experiencing? So my philosophy as a technology designer is that the way to make technology good is to work with your end users. Ask them what are the problems that they're actually experiencing. Ask them what do they want people to be working on. I have to be very aware that a lot of the sign language technologies that do get produced are often disability dongles, because they're something that someone hearing has come up with for a problem they think exists without actually checking, is this a problem that really does exist? So the approach that I take is called participatory design, where we work with potential end users. And in this particular project, we want to celebrate and center deaf people's needs, abilities, and insights. This is important. It improves the development process because it means every decision in our process is about addressing deaf people's needs and wants in the technology. The data that we collect throughout the project is focused and appropriate. The expected behavior, the behavior from the system is what deaf people would expect it to do. And we have human verification of accuracy of that behavior. From an AI perspective and data gathering perspective, it also promotes community control. Deaf users are able to stay in control of the data they provide. At every stage of the process, we are explaining what data we're collecting, why we want to collect it in a particular way, and asking what data they would like to contribute. So they get to choose what they're including and who has access to it. I have in my informed consent packages that I send out to participants a quite detailed informed consent page where I ask them things like, may we use this inside our project? May we use this for related projects outside of the immediate one, which has been very useful for some of my students' projects. May we publish this data widely and make it available? If it is widely available, do you want to be anonymized if we're able to do that? Questions like this, which supports the deaf people's sort of control and ability to choose at every stage of that process. So obviously this is an ongoing project, but some of the things deaf people have told us they would want from this type of device are things like being able to find information. Weather, sports scores, news, and recipes are some of the most commonly requested things. Being able to show and edit your calendar, control smart devices around the house. Smart doorbells, for example, are very popular amongst the deaf community because you can't necessarily hear a knock, but if your phone vibrates, you can pull it out and have a look without having to go open the door. They want to be able to set alarms and timers. Some of them want to be able to program specific behaviors. So show me the news when I wake up, or turn on the lights in the AC when I'm on my way home. They also want notifications, information, and warnings, but particularly the thing that stands out to me as something that's a bit different from what a hearing person uses the Alexa for on a day-to-day basis, is they are really interested in something like smart alerts. Possibly not what this will end up being called, but this is identification of things like, the train lines are down today. The sort of thing that a hearing person might casually hear on the radio on their way out the door, that a deaf person won't. Or if there's been an update to the COVID restrictions, being able to get that information unprompted would be useful. So that's sort of the background. Why are we doing this? What's the approach? The idea behind this project when we started it was that we're reaching a point in AI technologies that a lot of the problems we're trying to solve have open source solutions that we can take and adapt and build on. That has turned out not to be as true as I had hoped, but I'll get onto that in a couple of slides. Now, obviously, we're not working in a void here. Having the ability to recognize, process, and produce sign language output is something that deaf people around the world are interested in. So academics and companies from around the world have also been working on it. Fairly recently, Google and the University of Tokyo launched a sign language recognition website. Let's see if the video will work for me. And let's just mute that. The idea being that this particular website will teach you a couple of signs in Japanese Sign Language. And it will be just based on the webcam. It will track your movements. You'll be able to sign and it will go, yes, I recognize what you have signed. I did try it. I personally could not get it to recognize my signing. Could be I'm not very good at Japanese Sign Language. Could be the quality of the webcam I was using. Could be the quality of the AI, because this is one of those known problems. There's also been some work on producing signing. A lot of approaches have this sort of two-stage process that we can see here, where from English words, it generates skeletons, which control where the hands are, possibly control what the face is doing. And then that can be used with a generative adversarial network to produce video with, again, varying levels of quality. And the state of the art research on this does get reported as relatively readable. Now, this is an AI project. The stuff that's already out there is also based on AI, usually some version of machine learning or deep learning, which means we need data. This is a problem when it comes to sign language technologies. Compared to English, there's no data. Like, there is definitely some data for sign language AI, but the English language corpus of recorded, spoken, and written language data is immense. To the point where we've now got two competing publicly available English language models. The big one that you might have heard of being GPT-3, and Facebook/Meta/ whatever they're calling themselves nowadays have just released a massive language model for research use. In English, we're trying to work in Auslan, which obviously as a sign language does not have a written form, which means that all of the data we can work with has to be videos. There are some Auslan videos floating around the place. We have access to a very small, well-annotated data set of people telling fairy tales. We're also going to be collecting and annotating data through this project. But that's going to be really quite focused on the specific commands that deaf people have identified as being some of the most popular ones, so that our prototype can hopefully learn to recognize the specific commands. So there will be an awful lot of things like turn the light on, turn the light off, find me a brownie recipe, find me a chicken recipe. We're able to use some New Zealand Sign Language data. New Zealand Sign Language is a related but different sign language from Auslan. I have heard some different estimates of how much overlap there is, but their sign language dictionary, which is online, has some really spectacular videos which are well annotated of both individual signs and signs being used in a sentence. We also have video from ABC and 7 News press conferences, because certainly since 2020, just about every press conference you'll see has an Auslan interpreter. Not every video shows the Auslan interpreter, but that's, again, a different conversation. Now, these are useful because we get what is being said in English. We can see what the interpreter is signing, but they're missing the individual sign transcription and sometimes time alignment. Because it's an interpretation, there's a slight lag in the interpreting into Auslan. So this means that all of the AI stuff that we're doing, for best results, we're hoping to not work on Auslan first. We're hoping to work on some of the other data sets for other sign languages around the world, which are a little bit bigger, and then be able to transfer learn to Auslan, which means we're not going to be, hopefully, as punished for having a smaller amount of data. So there are data sets out there. Currently, we're working on the How to Sign American Sign Language data set. But this has been a bit of a process to try out different data sets and see what has enough data to be useful, while at the same time having enough similarities to Auslan that we're not losing anything with the retraining. So sign language recognition is a really complex problem. And like I said, at the start of this project, I felt really confident. This was a mistake. I'm aware, I should know better. But the thought process was, there's been a lot of work done in video and image processing, including work on action recognition and video description. There's been a lot of work on how do we process time sequences, particularly in a language space, and obviously a lot of work done on natural language processing, including translations. So the thought was, we should be able to pull together some of the key learnings from each of these fields to build on it. But what we've been finding is that we might actually need to be treating sign language as its own domain in AI. Even though it looks like a video problem, it is both a video and a language problem, and so has complexities for both. So some of the problems that we're trying to tackle at the moment is, when we've got our video stream, how do we figure out what is a sign, what is the movements between a sign, and what is a non-sign movement that we can help safely ignore? How do we then go from individual signs to understanding what that means? And how do we go from the string of signs that makes up the sentence or phrase, but with a very different grammar than we have in English, to something that we can spit out in English? Or at the very least, put into the right order to trigger something within the processing system. That's the input side. That's only half the system. Obviously, we also need it to be able to sign back. The approach that we're choosing to take is using an avatar rather than something video-like. Now, quick reminder again, state of the art at the moment for sign language production is doing something video-like, as you can see on the right-hand side here. So we're taking a different approach. If this is going to cooperate, let me show you. Sorry, just let me check if I'm sharing audio. I cannot tell. There may or may not be music in this next bit. So that's Alyssa, who is the avatar that we have been working on. At the moment, she's activated entirely by motion capture. And as you can see in the pictures here, we have my RA, Julie, and our team animator, Maria. So far, everything, like I said, is motion capture. As you can see from the suit Julie is wearing, we have full body capture, gloves for hand capture, and an iPad, of all things, for face capture. Turns out the best quality, relatively low cost way to catch facial expressions is with an iPad. I was shocked, but hey. So the idea behind it is that we record Julie's signing. It then gets processed. Some of this is automatic, some of this is manual, and Maria goes through and does some edits as required. And then the animation gets applied to the 3D character. The approach that we've taken so far is some of the recordings were longer form ones, like the introduction video you've just seen, but most of the videos were actually really short. A couple of signs, because what this allows Maria to do is set up essentially a state machine inside, where the avatar most of the time is going to be in an idle mode. So, that could just be standing there, could be kind of idly looking around. And then when it gets attention, that triggers the pay attention to the person signing at you. And then based on what they sign, triggers some different responses. At the moment, we don't yet have the automated triggering of responses part working, but yeah, we can type in which phase we want to go to and get the trigger, and also when necessary, get the movement between the different states. Okay, so that's great, obviously, as long as we've got something recorded. We can't record every possible Auslan sign or phrase, only the most likely ones. So our plan is that we should have a mixed activation of the avatar. Mostly this, bog standard, what we expect to be signing a lot will be pre-recorded phrases, but then we'll also have some AI generated responses. This is again, another kind of AI where we're going to have video of people signing that we train the avatar system on, which will allow us to generate skeletons like the ones we see back here. Sorry, further away than I remembered. So either the middle or the right-hand side gives an example of what we mean when we're talking about skeletons. It is tracking the relative locations of the fingers, the hands, the body as a whole. So I did say that state of the art is currently using video generation. We decided not to go with video generation for this project because we think that having to only generate the skeletons, which will then map into the avatar, should be a simpler task than generating a whole video, which will hopefully reduce the computational costs and all of the problems that go along with it, like, you know, not needing to burn down a rainforest every time we have to train a new model. The physicality of the avatar should also hopefully provide for a lower bound on visual clarity, so and an upper bound on uncanny valley. So the avatar is always going to look like a human being. We won't get any weird artifacts like we've seen in some of the former state-of-the-art video generation. Another problem that we see with video generation is that currently the video has to be modeled on a real person who is fluently signing so that they have something to map the video from, which obviously could cause a problem if someone, say, convinces their Alexa type device to sign something really rude that they then record some member of the community or an interpreter, you know, signing something rude. There's potential reputational effects. The avatars, on the flip side, have the advantage that they can be customized to suit the individuals using it. The avatars can also be integrated into a modular pipeline where content, like our pre-recorded phrases, can be edited without having to regenerate video, regenerate avatar. It just slots in very nicely. So the part that most excites me about this talk is some of the results I'm able to report back to you guys from a workshop that we ran only 2 weeks ago. One of the findings that we had from our avatar co-design workshop was this device should be culturally deaf. Now, what does that actually mean? When we talk about cultures, we often think about around the world, different countries have different cultures. But we're also aware that countries can have subcultures within them. If you think about perhaps the Australian Italian or the Australian Chinese subcommunities, these have their own cultures that are a blend of, you know, their home countries, or, you know, historical countries, and Australian culture. For deaf people, they're usually Australian, you know, as far back as they can remember. But there's still a language community which has particular communication and cultural norms. Deaf culture is actually really interesting from the perspective of something like 95% of deaf kids being born to hearing parents, which means that unlike the Australian Italian or Australian Chinese community, you're not getting a parent to child passing down of language and culture, but a sort of horizontal community-based transferal. If anyone does want to know more about that, please ask me a question towards the end of the talk. I think it's fascinating, but I should actually tell you about the project. Okay, so newest results that we've got, it needs to be deaf. We were trying to ask them, you know, should it have a particular personality? If you think about an Alexa or Siri, most of the communication is neutral, moderately formal, unless you're asking something specific like tell me a joke. And what we were getting back was it's not so much about a particular personality, a particular tone or register, but about being able to understand deaf communication norms. We had a role play activity where, you know, someone was pretending to be the avatar and the person using the device said, "Hi, how are you?" or signed, "Hi, how are you?" Because that's the deaf communication norm. That's how you greet someone. We also know that because for signing the whole body is involved, there's no such thing as a neutral inflection. The emotion that you're conveying when you're signing influences the meaning of a particular sign, and in some cases can change it completely. My favorite example of this is the word funny. Much like in English, this can mean funny haha or funny weird. The sign is the same either way, but the facial expression. You're so funny. You're so funny. very different. Because it can't be neutral, this means it has to have tone. So we have to figure out, are we matching the tone of the user, or are we adapting to the tone of the request? The overall sort of decision was most of the time it should be relatively casual or friendly. For something official, it should perhaps be a bit more formal. And if there's an emergency, it should be something bombastic or dramatic. Hey, did you know the trains have stopped, for example? The question of deaf jokes came up. Jokes in Auslan, very different from jokes in English. Probably also not something we could generate. So this is something that if we're going to include, we'd have to do a lot of motion capture work on. Obviously that's not impossible, but it's definitely something to think about to try and provide the same level of functionality as a spoken Alexa would have. Another big problem that we've got to address is the flexibility of language. So much like the early Alexas and Google Homes famously struggled with accents, in Australia, we may have difficulties with the Auslan dialects. Because Australia officially has 2 major dialects, but each community in each city and region has some of their own variations. So being able to recognize, multiple dialects is important, and then being able to sign back in the dialect that is appropriate for the person who's using it could be something that's really important. Auslan also has a lot of grammatical flexibility. So for those of you who have an Alexa, Siri, Google Home, etc., you've probably noticed that you have to speak in a very particular way, usually a very formal way, to get it to understand you and do the thing that you want. We may not be able to rely on that in Auslan because the way an Auslan sentence is structured is quite different from the way an English sentence is structured. We'll often hear about English being SVO, subject, verb, object. Auslan doesn't have that. Auslan has the topic, the thing I want to tell you about, and then the comment I want to make about it. So like, expensive red car I saw today would be roughly the structure of that. If there's multiple comments, that gives you a lot more flexibility in there. We've also got some interesting problems in that context conveys a lot of meaning in sign. And because it's a gestural language, it happens in multi-dimensions. If I'm telling you a story about my sister and my friend, I will locate them in space so that I don't have to keep saying my sister, my sister, my sister. I'll say my sister here, my friend here. So my sister gave to my friend something, a present, a scarf, whatever it happens to be that I'm telling you about in this story. This is not something that has so far been addressed in the sign language literature, but it's obviously something that's going to be really important to address if it's going to understand the way real people sign. We've also got the problem of what's sometimes called lazy, or more properly called informal signing. Because signing happens in the whole body space, I literally do mean the whole body space. I'm not sure if I can get far enough back. So if I want to sign dog, for example, it happens literally on the top of my leg. If I want to sign angel, I'm signing up here, literally above the head. Whole body's involved. But much like speakers in any language, the average person is a little bit lazy. Australians in particular, we're very good at, no one is called Jonathan, everyone's Jono. So if I'm signing angel, I might not sign it up here, I might sign it down here. Having established it once in the conversation, you know what I'm talking about. So this sort of informal signing is very common, but makes it more difficult for us to get a sign language recognizer working because we're changing one of the parameters that we were potentially training on. But that's also an expected norm. We were complimented on our avatar having some informal signing back to the people who were testing it for us a couple weekends ago. But they also said, on the one hand, it makes it feel very real, but on the other hand, it might make it difficult for someone to read, especially someone who is perhaps not fully fluent. For example, if you've got a mixed household with a deaf person and a hearing person who is in the process of learning signing. We talked a lot about the customization of appearance and function. The fact that it's an avatar means that it can be customizable. So we had questions like, should it look or behave differently for different members of the family? Possibly. Again, if you've got deaf and hearing members of the same family, should it be able to respond to both Auslan and English? Should it sign faster or slower, depending on who's signing to it? Should different users have different permissions and things that they can do? So, you know, should the parents be able to do more than the kids and the kids be able to do more than guests who are coming in? Should it be Auslan only? Should it have captions? Should it have English text only? If they're signing, should there be mouth movements? Probably. Most people said that they would want the mouth movements because, like we said, face movements can really influence what a sign actually means. But for some people, the mouth movements are distracting and they prefer to have a much, you know, more stoic experience. The overall feedback was it's good to have some control, but too much choice can be overwhelming. But the flip side of that is deaf people come from all races. Having an avatar that resembles your culture can be really important. And then, of course, the big question is, what do we name it? So far, we've been calling our avatar Alyssa because it's, you know, very similar to Alexa. That's a problem because if you're deaf and someone mouths the word, there's no difference. You cannot tell. So it might need to have a unique name. It might also need a unique sign name, which is a feature of deaf cultures around the world, which is a particular sign that means the person, or in this case, the device. And that may or may not be what we need to activate it, in the same way as you have to say the key phrases of Alexa, Siri, or OK Google in order to activate an existing device. And if it has a spoken name, it needs to be something that's easy for oral deaf people to pronounce. So overall, I think it's a really important project that we're working on. And I know that might sound slightly out myself to say that, but it's something that deaf people have actually said, this is a technology that we want. We feel like we're being left behind and we want to not be left behind. It's wrong for a particular community to get left behind as technology is changing. As we move into what could be a world with more and more voice-activated technologies, we don't want anybody getting locked out from being able to use that. Obviously, there's a lot of problems to overcome from a technical perspective, but I feel confident that we'll be able to get to a point where we have at least a prototype by the end of this project that shows, you know, yes, this is possible with more time, more data, more investment, and importantly, buy-in from the community. Okay, thank you very much, everyone, for your time. I'd like to open up the floor to questions if anyone has any.
Thanks, Jess. That was fantastic. Really fascinating. And I really like how some of the designs, like just the concept of inclusive design, really does mean that you are reaching more people than just, not just, but it goes beyond the target audience to a broader audience, I think. So very keen to hear from you all, from any questions or comments that you'd like to make. Jess, do you want to stop sharing your screen?
Yes, I can do that.
We can see people more easily.
Very interesting presentation, Jess. Really enjoyed it. I must say we should definitely have a chat because I have some research projects around avatars, animation, and language. And not targeting deaf people, but the focus is different, but I can see a lot of similarities. So we should definitely have a conversation.
Yeah, that'd be good.
Really enjoyed it. Thank you.
Thank you.
Jess, I was intrigued by your commentary about the lazy speaking of the avatar and the reaction to that, because I think that's a really interesting phenomenon of people saying, yes, that's positive, it's more natural, but it also makes it more difficult for people who are not trained to actually get that. Would there be a way for the system to essentially try to pick up the level of laziness from the person talking to the system as an indicator of how the response could be done?
Possibly. So this is actually something I've got a couple of students working on at the moment, of one of the approaches to AI that's been developed actually within ITI, is something called Slate AI, which is the synthetic language, I think it's just AI technology, something. I'm no good with acronyms, but the idea being that you can treat any sort of input as language, not in the language sense, but in the mathematical sense. So we have a set of characters, or an ordered set of characters, that allows us to say how frequently are we seeing particular patterns. Now, if we had a system that was, probably more traditional AI for recognizing the actual signs, but running a Slate type program that's also going, over the last 5 minutes, most of the communication has been very formal, very crisp signing, or mostly crisp signing with a couple of errors in it. This is probably someone who's not so experienced with signing, be more formal, versus the person signing to me is very casual and very fast. They're probably a fluent signer. We can now be more casual in response. That's the theory. Anyway, it is still untested.
Jess, can you see a possibility where your avatar could actually teach sign language to people who are interested in learning this as a new language themselves? So
solid maybe.
Solid maybe, I love it.
Okay, so it's the sort of thing where if the avatars got good enough and had a big enough base, then yes, theoretically it should be able to demonstrate signs. The problem that we have is that the Australian deaf community and deaf communities all around the world are pushing for greater control of their language at the moment. So we're getting, lots of controversial situations. Hell, I got linked another one yesterday where people who are not interpreters, are not in fact fluent at all in any sign language, are pretending to be interpreters, getting hired, and then very important press conferences are completely inaccessible to deaf people. Similar, but not quite so bad, is then people who are not fluent signers teaching other people with very poor signing, and often missing the cultural norms that are really important when it comes to signing. So if it were able to do that, it would have to be fully with the blessing of the Australian deaf community before I'd be willing to do that. But the flip side of that is if it does get approval, or if it's solely as a support rather than the main thing, it could be a really useful tool for someone who is learning from a deaf person but wants an opportunity to practice. Because as a hearing person learning to sign myself, my biggest problem is I don't have many other people to practice with. If I had a device where either I could have a conversation, or perhaps more likely I could sign and it said, "Did you mean this?" And I go, "No, I have gotten that sign wrong. Please show me that sign," and then I can watch and practice. That would be something that's useful. Having it as an avatar would also mean that I could do a mirror thing with it, because Auslan is how you sign depends on which is your dominant hand, which means that my best experience was learning from a left-handed teacher as a right-handed person, because I could mirror copy the way she was signing. With someone who's right-handed, there's that extra step of, hang on, what does that look like from your side? Yeah. So yes, solid maybe.
Any other questions? I think it's great that your ITI colleagues have come out in force to support you, Jess. That's really good. So we will be putting this, the recording of this talk on our faculty intranet, and obviously we can make it available to whomever wants it as well. So, so it will be more broadly accessible and hopefully more broadly understood as well. The other point I wanted to make actually was the link with design. You mentioned design quite a few times, and obviously now we have a Bachelor of Design in the faculty, and the School of Architecture is the home of that. I think it would be really useful to connect there and potentially present to their students around, you know, designing things that would be useful to different communities. So
yeah, for sure.
So I think that would be really helpful to our students to learn about how we can be inclusive. Okay. Thank you everybody for coming along. And thank you very much, Jess. And I think I learned that clapping in sign language is this. Is that right? Maybe I'm doing it wrong, but anyway, so thank you everybody. And thank you very much, Jess.
Thank you. Thanks all for coming along.
Good job.